So in the second part of the quiz review, I'm going to go over the last half of the review. So question 8 says, calculate and interpret the coefficient of determination, r squared, in the context of the problem. So r squared, you literally take your correlation coefficient, which in this case is negative 0.85, and we square it, which is going to give us 0.72. So the coefficient of determination, so this would be, so we convert it to a percentage, so 72% of the variation in the response variable, which is in the day cherry tree blossoms, can be explained by the explanatory variable, which is the temperature in degrees Celsius. So now what we want to do is calculate and interpret the residual for the first point in the data set. So our first point in the data set is a temp of 4 and the day is 14. So using my equation, we're going to do y equals negative 4.67, and then instead of x, we're going to plug in our temperature, 4, plus the 33.12, which is going to give us 14.44. Okay, so our linear regression model tells us that if the temperature is 4 degrees Celsius, then our predicted value is that the cherry tree will blossom on the 14.44 day. Okay? So then to calculate the residual, we take the actual value and we subtract the predicted. So in this case, our actual value is 14 minus our predicted 14.44, and we're going to get a residual of negative 0.44, which is not a bad residual in general. Negative 0.44, our predicted value is very close to the actual. Now in the general case, like, we don't know if this is actually a good residual or a bad residual. Without calculating the residuals for all of our data set, we have no way of knowing if negative 0.44 is a good residual or not. A lot of our other residuals could be 0.0 something, in which case 0.44 is still a good residual, but not as good. A lot of our other residuals could be like 5, 6, or 7, in which case a residual of negative 0.44 is really good. So you can't really interpret how good a residual is without knowing the rest of the residuals for your data, which is actually what we're going to take a look at next. So I was actually able to graph residuals using Google Sheets. Please check out the video on Classroom I created going over how to do this on Google Sheets. So what I was able to do is, along the bottom here is our X value, which is our temperature in degrees Celsius, and then the residuals for each of our 24 values. So the better a linear regression model is, the closer your residuals are to this 0 line. So we want a lot of our values to be close to this 0 line. Now, in looking at our residuals, not a lot of them are really close to 0. Most of them fall outside of the 2 and negative 2 range. So looking at our residual plot, this is going to tell me that my linear regression equation is not a good fit for the data. Now, if a lot of our residuals had fallen between the 2 and -2, of course, but even being outside, like even being between 2 and -2, like my residuals are even closer to the 2 and -2 than they are to actual being 0. So if I were looking between 1 and -1, instead, my residuals would be even farther outside. So I would definitely say my linear regression equation is not a good fit for this data. Again, please check out my other video on how I did this in Google Sheets so you can do it on the quiz when you take it. So next we want to know which observation has the biggest residual and is it unusually large. So the biggest residual doesn't mean that it has to be a positive biggest residual. It can be a negative biggest residual. It just means the biggest. So if we're looking, again, you're gonna wanna refer to my video on how we created the residuals on Google Sheets. So what we're gonna wanna look at is the table we created on Google Sheets, and we're gonna look for the residual. And if we look, we have a residual of -7.18. So a temperature, so the temp of 3.2 has a residual of -7.18. Now, asking if it's unusually large is comparing it to the other residuals. So do a lot of other residuals fall close to 7? Do most of them fall shorter than that? And if I'm looking 3.2, -7.18, there's not a lot of values that come close to that. So I would say, yes, it is unusually large. Most of our residuals fall between 1 and 4. Now, obviously, if a lot of our residuals were even smaller, between like closer to 0, -7.18 would be unusually large. If a lot of our residuals were around 5 and 6, -7.18 would not be unusually large. Again, it's completely based on your data. It changes for what your residuals are. Okay. Number 12, if the temperature was measured in degrees Fahrenheit, what values would change and how? So our linear regression equation is definitely going to change, because we're going to have completely new temperatures now for the exact same y value, because our day isn't changing, just the temperature. So our linear regression equation is going to look completely different now. Our slope is still going to be negative, and our y-intercept is still going to be positive, but now it's going to be based on degrees Fahrenheit. So a temperature of 0 in degrees Celsius is not the same thing as a 0 in degrees Fahrenheit. So then our interpretation of the x and y-intercept are also going to change. So the lowest temperature for the cherry tree to bloom in March is going to be different in degrees Fahrenheit. And then also the coldest day for it to bloom in May, that's what the y-intercept is, when our cherry tree blooms in May, is going to be different for when the warmest temperature for the cherry tree to bloom in March. That changes based on the fact that we're now talking about degrees Fahrenheit instead of degrees Celsius. Our correlation coefficient is not actually going to change. The relationship between the two, correlation coefficient isn't actually affected when you change units. The relationship is still the same. As the temperature increases, the earlier the day the cherry tree will bloom. So that's not going to change. Okay. Lastly, we want to predict the data of the first bloom for an average March temperature of 3.5. And then we want to know, do we feel confident about our prediction explained? So again, we're going to go back to our equation. y equals -4.67, and now we're going to plug in 3.5 plus 33.12. So evaluating our equation for 3.5 is going to give us an average day of a predicted day of 16.78. Now, feeling confident about that prediction is based completely on whether or not we think our linear regression equation is a good fit for our data. And because we determined, based off our residuals, that our linear equation was not a good fit for our data, I would not feel confident about that prediction. So, not confident because our linear regression equation is not a good fit. Now, if we had decided that our linear regression equation was a good fit, then I would feel confident about our prediction of 16.78 days. Okay. Please let me know if you have any questions over anything from Chapter 3 before you take your quiz. Again, please make sure you check out the video I created on the residual graph, and if you have any questions about how to do that in Google Sheets, please reach out to me.